All right, this is the applications are epsilon delta, our definition of a limit. So we're not going to be really dealing with epsilon and delta in this application. It's just to show you their relationships and how they actually work with stuff that we've been dealing with before. So a machinist is required to manufacture a circular metal disc with an area of 1,000 centimeters squared. So that's our area. And if you remember, area of a circle is pi r squared. So what is the radius that produces such disk? So if we plug in that area, it allows us to solve for r. And we don't deal with, so this would be the square root of 1,000 over pi. And then we plug that in our calculator. So second square root of 1,000 divided by pi. And we're going to keep this in here and not forget where it is, but this is just for reference of what it is. So 17.8412. We're going to be using that over and over again. So that is our radius that we want. So if the machinist is allowed an error tolerance of plus or minus 5 centimeters squared, that's the area in the area of the disk. So this is our error. So you've got to think about it this way. Our area is 1,000 centimeters squared plus or minus 5 centimeters squared. So it's saying how close to the ideal radius. So our radius here is 17.8412 centimeters. We should really put the units on there. In part A, must the machinist control the radius? So this is our epsilon delta that we've been dealing with. So you can see here that that's our epsilon, and what it's asking for is the delta. So if our area is 1,000 plus or minus 5 centimeters squared, then what we're saying is this is our area, this is the radius that it gives us, and that's our formula, a equals pi r squared. That's our f of x in this case. Then we know that our limit is 1,000, and we're going to be able to go up 5 or down 5 here. So minus 5 plus 5. And so this is our epsilon. The 5s are our epsilon, and that's our limit L. And then the radius that gives us that is right here. And this is just a parabola, right? We already know it's pi r squared, so we know it's a parabola that it's going on, stretched by pi units. And so following this up and over, you can see that's our limit. So what it's asking for is for us to do what we've been doing in these other problems. So we're going to find that one, and we're going to find that one. So just by working backwards. So we plug in 1,005 into our formula, and we find r. And we plug in 995 into our formula, and we find r. And then we want to know is what is the ideal radius? How close to the ideal radius do we need? So again, we're looking for delta. Okay, so let's solve for this. And so this is the same idea, r equals, and it would be 1,005 divided by pi square root, just like the work we did above. So if we plug those in our calculator, it'll tell us what we get. So second square root of 1,005 divided by pi, and then second square root of 995 divided by pi, which gives us this. All right, so we get 17.8858. And for the 995, we get 17.7966. So 17.7966. These are our radiuses. And so I want to place them on there where they're supposed to go. So the 995 is the 17.7966. And the 17.88 came from the 1,000. So working in reverse, if we were to plug this radius in, it would give us that area. And if we plug this radius in, it would give us this area. And so remember, we need to make sure that whatever we have for our radiuses, we are within 5 units of 1,000. So this is why we're doing an application to show you the relationship between epsilon and delta. So now we just subtract them, right? So we're going to plug them in that x minus. So we're going to go 17.8858 minus 17.8412. And then we're going to do 17.7966 minus 17.8412. And the smaller one that we get, that's the one that we want to keep. So we're not going to call it delta though. 17.8858 5/8, which is a quicker way of doing this. You just go up and grab them, and it's going to be more exact. So that one minus that one, and hit enter, and we get 0.0046. 0.0446, 0446. I said that wrong. All right, and then we do the other one. So now the 995 minus our original of 1,000, and hit enter, and we get the same number, which is nice. So we know that it has to be 0.0446 away from each other. And so if you want to check this with your calculator, you can as well. So again, we put in our function, so pi r squared. And then we put in the two values that we have, so 1,005 and 995, and then we go to our window to make sure everything works. So we're right around 1, right? 17, I mean, that should say 17. I put 1. 17.8412 right there. So around 17.8412, we don't have to go that much farther from it. So why don't we do 17.6, and then we'll go the same direction the other way. So like 18. And then we're between 995 and 1,000, so like 990 should be good. We just want to make sure that we're not giving a massive picture that's going to be hard to see stuff. So 1,010. These are just arbitrary numbers I'm just picking from. So now when I hit graph, it will give us the picture that we're looking for. So there is our line. You can see it looks like a line. That's why these are so close, is because we're so zoomed in here. We're at 1,000 with a very small error. And there they are. And so remember, that's the first one, and we should be getting 17.796 for that one, and 17.8858 for that one. So second calc intersect, 17.8858, perfect. Second calc intersect, and this time we want to do blue with black, enter, 17.7966. So perfect, everything works out. And now if these were different, remember we always picked a smaller because it's that same idea that if you pick the larger one, then one side is going to be too far out and we're going to be outside of that range. We need to make sure that we're within 5 up or down. So you have to pick the smaller one to make sure you stay within that area. Okay, so now how does this relate with the problem? So our L here was 1,000. Our f of x was the pi r squared. Our epsilon was the difference. So in this case, it's the 5. Right? And then our A here was that radius, 17.8412. And then our delta here was our 0.0046. So in terms of our epsilon delta, this limit, what is x? And so x is the radius. What is f of x? F of x is our area, which is pi r squared. And what is L? L is 1,000. It's our limit. What was the value of epsilon? Epsilon is 5. And then what was our corresponding delta? Our delta was 0.0446. So if you look at it, when you do these problems, the error in our function is our epsilon. The error in the radius is our delta. And that center point that our limit is approaching, that is our A here. So our A, if it had asked us for it, was 17.8142. So we could even have said A equals 17.8412. It's the radius for that 1,000. These two have to match, that one and that one. They go together with our function. And there you go. Thank you.